This is 9-5 system applications, which just means these are systems of equations, and you can solve them by any method. Some of you will see these. Please make sure when you are writing them out, you show me your thought process. Okay, there are 22 students in a classroom. There are 12 more girls than boys. Find the number of boys and the number of girls. So whenever I've taught this before, I've had some people just start fishing. 0 girls, 22 boys. And then they would go 10 girls and 12, and that's a difference of 2. And they would just start listing them. Takes a long time. Actually, it works, but it takes a long time. So there are 22 students in the classroom, and we know that there are girls and boys. So the first statement says girls and boys is 22. And I let G equals girls and B equal boys. There are 12 more girls than boys. I'm going to write girls equals boys, but that's not true because there's 12 more of these. So in order for it to be equal, I'm going to have to add 12 to the boys for them to be equal. So now I have two equations. This is beautifully set up as a substitution. So these are my equations. I'm going to do the substitution where I'm going to let the G equals B plus 12. So B plus 12 plus B equals 22. 2B plus 12 equals 22. Subtract 12, subtract 12. 2B equals 10. B equals 5. So if I have 5, but there's 22, I have 5 boys and 17 girls. And 5 plus 17 are the 22 students. And 17 minus 5 is 12, so there are 12 more. And that would be your answer. Marta has twice as much money as Heidi. So Marta equals Heidi. No, that's not a true statement from the first one. If Marta has twice as much as Heidi, then in order for them to be equal, you have to multiply 2 times Heidi. You can always divide Marta by half, but I want to stay away from fractions. Together they have $36. Marta and Heidi equals 36. Another beautiful substitution. So I have 2H plus H equals 36. 3H equals 36. H equals 12. So Heidi is $12. Marta has twice as much, so that's $24. And I go back to Marta has twice as much as Heidi. That is a true fact. Together they have 36. That is a true fact. Alan rode his bike 3 times as far as Bill. Alan equals Bill. No, it says that they're not equal. It says Alan rode 3 times. So I either have to divide this by 3 or multiply that by 3. And I'm going to stay away from fractions. Alan rode 16 miles farther than Bill. Again, Alan equals Bill. No, he's 16 farther. So for him to catch up, he has to equal 16. Okay, this is a great substitution. Whether I put this here for that A or this here for that A, that's fine. So I have 3B equals B plus 16. And I always put it under, you can put a box around your statements that you created. 2B equals 16. B equals 8. And then 8 times 3 is 24. So Bill equals 8. 3 times amount, so Alan rode 24. And 8 plus 16 is 24. So that's your answer. A pet shop has a collection of 15 cats and dogs. Okay, so I want to talk about this phrase right here. That's green eggs and ham. And if you remember the Dr. Seuss book of Green Eggs and Ham, it's green eggs and ham means green eggs and green ham. So this is 15 cats and dogs. That means that total, so it's this, a total of the 15 cats and dogs. So it says cats and dogs equals 15. It doesn't say 15 cats and some dogs. It says I have 15 cats and dogs. Crazy. There are 4 times as many cats as dogs. Cats equals dogs. No, there's 4 times as many cats. So I either have to divide that by 4 to get it equal or multiply the dogs by 4 to get it equal. I have my 2 equations. Put them in a box if you'd like. I'm going to do substitution. 4. And I'd be careful of using D's. Mine start looking like zeros. 4D plus D equals 15. 5D equals 15. D equals 3. So if D equals 3, then 4 times 3 is 12. So dogs is 3. Cats is 12. And together 3 and 12 is 15. So set up your equations. Most of them will either be substitution. If you by chance get a standard form equation, I'd solve it by elimination.